got all the pieces printed here. I printed these in ABS like resin from eSun. It's their hard, tough resin, so I feel like it's a lot less brittle than just normal resins. These are all the parts basically for the arm, with the exception of the hand. The hand is the same as the Chillibasket version, so I'm not going to include showing that, but that basically just mounts to the end of the forearm with a little peg, and then it gets glued in there like that. So to start the assembly, make sure that after everything's printed, sand off all the support marks and anything you don't want to show. It's probably going to be a lot easier to sand these parts now than it will be later once they're assembled. The other thing you want to do is make sure parts fit together as they should without much effort. Once the forearm goes inside the body, it needs to be able to spin freely. There will be a little bit of play in it that will actually be taken up by one of the bearings up here, but for right now it needs to spin freely. If there's any friction, then that's just going to add to the pressure on the gears, and then they're going to end up stripping out. So make sure everything fits okay in there. We'll get to the servo mounts here. That's the cap. Here's the end cap. One thing I did have to sand, I'll probably modify the STL file, is I had to sand these surfaces here to get it to fit inside. You should not have to sand the cylindrical surface. It should fit inside, and it's just gonna pop in there just like on the Animate arm version. So okay, so first things first, we're going to install a bearing inside the body here. These ball bearings are really small. They're 3 millimeter hole diameter, bore diameter, 7 millimeters outside, and then 3 millimeters thick. So your first one should just basically press right inside that hole that's in line with the arm body. So that's kind of your first step, and it should just fit tightly in there. You shouldn't need any glue or anything like that. Okay, so a few more bearings out. You will need 4 ball bearings per arm. The first one goes in there. The next 2 go in the shoulder body. The first one should go right on the top there in the center hole, pushes in, and the next one goes in the bottom hole. And so if you use a 3 millimeter bolt, that should spin nice and freely on there. And then the last bearing will go in the bottom of the large gear that goes inside the shoulder gear. This one is a little bit tight fit, so I'll probably have to modify the STL, but it should press in there as well. You just got to push a little bit harder, so might have to modify that just a little bit. And that bearing should just about fit flush. Next step is going to be to install a 3 millimeter locking nut, the nylon lock nuts, into the forearm here. There's a slot right here that you'll want to put it in, and it basically should just slide right down inside that slot, and then push it down to where you can see it comes through and it aligns with the hole on the bottom side. So we're going to take the first gear that has the first small gear that has the center, the tapered hole in it. That's a round hole, and it's a little bit thicker, versus the other gear has a square hole in it, and it's also a lot thinner. You want to use the thicker one. Take a 20 millimeter M3 flathead screw and screw the gear into, screw the bolt into the gear. You want to make sure that you're going in straight. Just before you screw it all the way in, you want to add a little bit of dab of super glue into that, onto the threads there. Be careful to not add too much, because you don't want to get any super glue on the teeth. otherwise you'll have a problem with it binding, and it will strip and your teeth will break. Call that tight. I'm going to go ahead and hit it with a little bit of accelerator just to speed it up. Now this gear, if you take the body and you put the gear inside there, you have the threaded, the M3 screw coming through, which will go into this part of the forearm. So once that's in there, just hold this gear tight and screw your arm in to where it catches with that M3 lock nut inside the forearm. Now you get it too tight, it'll obviously lock up on you, so back it off just enough to where it's free spinning, but there's not much play in it, so you want it free spinning though. So that part is assembled. The next part, we're going to go ahead and take our large gear on the bottom inside the shoulder, the one that we put the bearing in. We're going to take a 25mm M3 screw. We're going to go from the outside of the arm here, outside of the shoulder, and again this is going to screw in there fairly tightly. But before we get it too far in, we want to take the M3, or we want to take the gear and place it to where it's underneath the small gear, and then the shaft will go through it. And with that in place, you can go ahead and check the meshing of these two gears, and they should spin very freely. There should be no tension there. In fact, a good way to check it is to take a small screwdriver and carefully move these teeth here back and forth, and if your forearm rotates, then you know you've got the right amount of friction, or not too much friction. So go ahead and we'll screw this down. Now, just as a check, we'll take our shoulder, slide it over the shaft, make sure that there's no tension, no binding there. Make sure that when we hold this in position, there's no binding. I actually feel just a little bit of binding in there when I'm up against the tight. So I think what the problem is that this inside edge right here is just catching, so I'm going to file that out just a little bit. I may have to make a modification to the STL file. There, now I don't feel any tension whatsoever. Okay, so that part is complete for right now. Next up, we're going to assemble the shoulder here. Okay, so with this, we're going to need the small shaft, the shaft with the hole in it, and the other two small gears. These, you want to sand these down. You don't necessarily need to sand down the inside of that, but you want to make sure that this gear, with there's two hexagonal ends. You want the shorter of the end going inside the shoulder. You want to make sure that that spins freely. And then also the smaller shaft with the longer end, actually this time, goes inside that, and it spins freely. So you can check them outside too. So everything needs to spin freely with no tension. The other thing you want to do is make sure that your the square ends will fit within your gears. So this is the small gear with the square end on it. You want to make sure that that fits in there fairly smoothly, but does not have any play in it. So the other one, you want to make sure that the short end fits inside the octagon shaped hole. So take the large gear with the hexagon in it, drop it down inside the shoulder. It only goes in from one direction. The hole on this side is bigger than the hole on the bottom. You won't be able to get it in there. So you want to bring it in the top here. kind of hold it in the middle with your two fingers, and then with the other end you want to bring in the shaft and kind of feel to get to align your hexagon up. And once you get it lined up, you're going to want to push it in there to where it fits. This again should spin freely. There should be no tension here. There's no need to glue this. It fits tight enough, and once everything is on inside the body, this shaft will not be able to pull out. So next up is the small gear with the square hole. It's going to go right in front of that gear, and then you're going to put this shaft with the longer square end on it through, and then just kind of push it in. And now you should have two gears, each spinning freely, free of one another, inside the shoulder. This then will slide over the shaft, and now you can see when I rotate this out, this larger gear, or the outside gear, rotates, and when I rotate the inside gear, you can see that the hand, you have to hold this down and the hand will actually rotate. A good test is to do it like this. Make sure it's working. Okay? So to hold this together now, we're going to take another M3 lock nut, and we're just going to put it right on top here. And then we're going to tighten that down. This all together. We do not want to make it too tight though, so I recommend snugging it down to where there's way too much tension, and then back it off just a little bit until there's enough free movement, but you don't want a lot of play in it. So maybe a quarter turn. It's still a little tight, so I'll do a little bit more. I've got a free moving shoulder, I've got a free moving arm. In fact, if I take the servo arm and put it on here to make it a little bit easier to see, and then you can see that that rotates at any position. And then, see, it actually pulled that out. Yep. And then we'll take the larger gear here and put it on the octagon shaft, and if you hold shoulder, your shoulder should move in and out like that. Okay. Lastly, the shoulder cap will go on there. Okay. So we're going to take our 3 servo horns here. We're going to prep these to mount to the servos. These servos, by the way, are these AGT micro servos. AGFRC, I think, is the manufacturer. They're titanium geared micro servos. They seem to work pretty well. They're 3.8 gram servos. They haven't had one strip yet. They actually have an aluminum body on them. I kind of like them. They're a little more expensive. They're about 20 bucks a piece, but they seem to work pretty well, and they have a full-size servo connector on them rather than those micro connectors on the other small servos. So we're going to take our servo horns. First one we'll do is this cross. So I used the cross one here, and you can see it's obviously too big for the gear. So go ahead and take a pair of nippers and trim off the ends. It'll make a cross. Chamfer for the corners too. A little bit. You can sand these. You can cut them. Whatever you want to do. The corners cut off and a little bit rounded. Take your gear, place it in the square, and then kind of push it down in there. Make sure it's nice and tight in there. Again, you can glue it if you want to. You don't necessarily have to. It's going to be wedged between here and here, so it's not going to come out, but I'm going to add glue just in case. Some glue around the corners. Don't get any on the teeth or on the servo arm. Go ahead and set that. Do the next one here. I'm going to take a larger arm. It's got a little nub we might need to clean up there. This should fit right inside that servo arm. Go ahead and press it in. And then add a little glue to set this one in there. Take the last one here and take the servo arm and basically just glue it in place in this one. This one's a little too big. We need to tighten this one up. Trim off the excess there. Those are your 3 servo horns. Okay. Go ahead and take your 2 mounts. This is the one that goes on the body. It has a form inside of it to locate to the sidewall in the Chillibasket version, or the Animate version, I guess. It also has 2 little slots here for nuts, and it also has a spot for your heat zerk. This one has 3 different spots for nuts, so you'll need 5 more M3 nuts. These then slide down inside their spots. I'm going to go ahead and put just a little bit of glue on them to keep them in position. Make sure this part is smooth, because this actually rides up against the sidewall. Okay, we'll go ahead and mount our servos. Take your first one, mount it in the little bracket here. You want the this bracket's going to go on the left side. So like if this is the front, it's going to go here. You want the servo end to be mounted towards the back, basically. I believe, yes. You want the wire to be coming out the back. So these are going to screw in from the bottom, just like this. this one is in this block. Your block that tilts you have a servo that's close to it and back from it. You can see there's 3 holes here. Those line up with these 2 holes, and then there's a third one that's all the way back there. So those go like this. So these 2 servos, you want the wire coming out of the top. So you'll want one right there, and then you'll want one right there. And those get screwed on from the back side as well. Servo on the top position. It. So now that we have our servos mounted, we can take our servo horn with the gear on it, mount it to the farthest outside gear here. Go ahead and put a screw in it. Want to center this servo. Set it to about 1500, close to it. Press the small servo arm with the square in it on. That'll get that one lined up. So to install the tilt servo arm, you want the servo arm to be fully rotated over, as far over, I guess in the counterclockwise direction. So that gives you the range. So that's full over at 2000, and that's over at like 900 or wherever it's at. So that's kind of where you want the angle that you want this arm at. So go ahead and screw that one down. Takes care of all the servo arms. Just as a test fit, you want to make sure that there's room here between this surface and this for the gear, that's free floating. If it's not, you can sand this gear down if you need to, but it should fit fine. And then you can see that these 3 get screwed together with 3 different screws here, and then a longer one to go through here. For the tilt linkage, I bought these 2mm ball ends online. They come with the ball end and then a small 2mm nut already kind of screwed on there. these little ball ends will screw into this little hole here on the tilt bracket, and then the end of your servo arm here. So sometimes you got to pull these apart. You'll need 4 total, 2 for each side. Take a 5mm socket. And go ahead and screw that in. See that the backside has a recess in it for the nut to go on. Just like that. Same thing on this servo arm here. You want to screw in the ball joint into here. Just like so. Lastly, we want to take a section of 2mm threaded rod, and if I lay out my ball joints here on the grid about 1.5 inches apart, you want a piece that's going to screw between them. So I'm going to mark my threaded rod here and right there, and then I'm just going to snap that off. And then these simply, this piece this threaded rod simply screws into the ends of the ball joints. So you want your linkage to be from ball to ball about 1.5 inches. kind of keep adjusting them until it's about 1.5 inches. And you want one ball to be facing one side, the other ball to be facing the other side. You don't want them on the same side. So, one more turn. So about that far. So, and millimeters from ball to ball, you're probably around, I'd say around 38 to 40 millimeters. Okay, and now you can snap one ball end onto the tilting bracket here. The other one will snap onto here once it's assembled inside the body. Okay, so the way these work is the shaft will go through the wall, but unfortunately I had to make this shaft a little bit bigger to accommodate for all the different pieces in here. So this is a 1/2 inch or 12.7 millimeter hole. The holes that are inside here are too small. They will not work, so you'll have to drill this out. I use a step drill bit like this. These are imperial units. It goes up to 1/2 inch, which is the same size hole that you need, 12.7. So as you drill this through, it goes in sections, and it tends to be a little more forgiving on pieces. These were printed in resin as well, so they're solid. If you're FDM printed, and most likely you're going to drill through your inner walls, excuse me, your outer walls, and you're going to have infill exposed. So right now I got to drill that out. Don't want it tight or it won't move, but you don't want it loose so it's floppy and moves on you. But that's still way too tight. That's pretty good. So when you put this on bracket, you should be able to move this fairly easily without it binding. That feels pretty good to me. Okay, so with the body cleaned out and the hole made, it's time to assemble the parts together inside the body. Take your arm, and preferably after you've glued this on, put it through the hole. Take the tilt bracket, and the way this is designed is when the arm is down at a 45-degree angle, this surface of the block here will be horizontal to the top of the body. So it's made to fit to where this is horizontal, this comes down at a 45-degree angle. I do recommend gluing this a little bit. Also, don't glue the shaft, glue the hole, and just put a little bit of glue in there. You don't need a lot. You want to make sure that you don't have any glue on the back surface, otherwise you'll glue it to this wall. And then just hold those tight to each other. Make sure your arm still moves freely. Make sure you didn't get any glue in there. Go ahead and hit it with some accelerator. And you should be good to go. Okay. Now you can take your larger gear with the hexagon hole. It can then go on the larger shaft. You can see how that turns, or you can test it like this. It'll work at any angle. Next up, we're going to screw in our back assembly. It's going to take 3 screws. Just like that. Now you can actually flip this over to get your screws in. This top one is a 20mm screw. These are all flatheads, 3mm screws. It's going to screw right in. That. The other two can also go through here. These are also 20mm screws. Lastly, one here. This one can actually be shorter than 20mm, but I figure rather than adding a whole nother size in there, I'd make it so you could use a 20 on this as well. It doesn't have to be 20 though. It is important that the screws don't stick out this back side, otherwise it'll rub up against the wall here. You want that to be smooth. Just like that. Now, if you'd like to test the arm, go ahead and hook up a servo controller. Make sure your arm is working. So you can see this one is the front gear here. This is what's going to rotate the hand. If you don't like the way it's positioned, or you don't use a full rotation servo, you might want to change the position of this servo arm, how it's connected to the servo arm. Like right now, mine's not going a full 90, so I'll probably take that off and adjust that position of that. That's the servo arm working. The other one is the arm in and out. You can see it moves in and out. And this is actually using the back gear here to move that in and out. Lastly, we're going to mount our inner block. This has a horseshoe shaped thing in it to align with the block that's inside on the wall. So it's just basically going to fit right there. I want to make sure that it's in there good and tight. I haven't actually put the 3mm Zerk in there yet, but that goes in exactly the same as the other ones. Just a heat Zerk goes right in there. So we're just going to go ahead and add some glue to glue this on the inside. Last thing is to install the tilt servo. So you'll have to reach inside and here's the linkage. You want to connect the linkage. And now your servo arm here is going to screw right to that bracket through there. And you can see how these are lowered down by these brackets. The head servo will fit. And then the tilting arm goes right between these, so you want to tuck these wires down inside. These can be shorter screws as well. I would recommend using a shorter screw, like say, I think 12mm works. 12mm will work. And then lastly, we'll go ahead and test the tilting mechanism. And there you can see the arm tilting up and down. And that's essentially it. And here you can see the head with the bracket here, and then the small servo flat to the top. That fits on there just fine. I don't know if you can see inside there, but you can see the two servos actually just about touch each other, but they miss. So there's plenty of room for a normal size micro servo in there. And that's it.